welcome. Thank you everyone for joining us today at our Pittsburgh Jug session. I know we missed like the last two sessions, but hoping that we can do this one and one in November and maybe take a break in December for the holidays. Yeah, you can find out more about us from our Twitter. I don't know what it is called now, but whatever it's called, we have a group, we have our account there. You can follow us for more information. And of course, the meetup group is where we would post our events, and that's where you will learn about our upcoming events and sessions. Let me do this. Yeah, so all of our sessions are recorded and we put them up on our YouTube channel, so you can always check them out later. If you've registered and if you're not able to make it, you can definitely go back and check it out at a later point. We would like to thank our official sponsors. So we have JFrog and also BNY Mellon. We want to thank them. And with that, I want to hand it off to Chandra. Chandra, if you can introduce yourself. I know you probably don't need an introduction, but if you could do that and you can take it away from here. I'll stop sharing.
Sure. Thanks, Sirisha. Hi, my name is Chandra. I have been working in the Java space for a long time, since '98. And I am a big fan of Apache Maven. And hopefully today's session will cover some of the basics of Apache Maven, how it's used, and some of the internal wirings of how Apache Maven actually handles a build management process. So that's what we'll take a look at. I'm available on Twitter and on LinkedIn and GitHub. So please feel free to reach out. My slides will have my Twitter handle. Yeah, that's the easiest way for you to connect. And as Sirisha pointed out, it's not called Twitter. I don't know what it's called. It's called X, and I don't like to say X. So whatever, I'll still refer to Twitter.
Yeah.
That's great. So that was about my introduction, and I'd like to start sharing my screen if it's okay with Rinat and Sirisha.
Yep. And awesome. We'll confirm if we can see it or not.
Perfect. Yeah. Great. So let me just share my screen. I'm going to share my entire desktop. By the way, just letting you know, so I'm a big fan of nature, and this is Acadia National Park in Maine. If you haven't visited, there's an amazing place to go visit, and that's my background right now. Just letting you know, awesome place to go visit in the fall. So if you ever are in the mood to go out for a drive, there's a place I recommend. Awesome. So let's go through the slide deck, and I promise to keep it short and painless, and please feel free to interrupt. This is not a coding session. This will be mostly a presentation. So feel free to ask questions. And if you're asking over the chat, I can request Sirisha and Rinat to sort of follow up and interrupt me as and when the questions arise. So with that, here goes. I'm going to share my full screen. Rinat, can you please confirm that my screen is still visible?
Yeah, we can still see it.
Great. Thank you. So I'm going to minimize the sidebar as well so I don't distract myself. So today we're going to talk about Apache Maven, and the title is A Peek Under the Hood. So what is Apache Maven? Apache Maven is a very powerful build management tool. It's not a build tool, it's a build management tool, and we'll take a look at why that is the case. It's primarily used for building Java projects, and it has been mostly developed in Java. I have, at some point in my life, contributed a bit to Apache Maven myself. It's an open source project. And more importantly, we'll try to understand what Apache Maven does in convention over configuration. The two items that are highlighted on the slide, build management and convention over configuration, will be expanded in the next few slides, so we get a better understanding of that. Apache Maven is not just for Java. You can build other programming language, code bases with Apache Maven. They have their plugins. We'll talk about those as we go along in this session. So let's take a quick look at what build management is. A build management is something more than or a superset of what a build tool is. Ant is a build tool. Gradle happens to be a build management tool, and Apache Maven is also a build management tool. Gradle has been heavily inspired by Apache Maven in a lot of places, but they both independently are very solid tools. So towards the end, probably someone will ask me this question about which tool is better. So I'm just going to answer it right away. Both tools are amazing. They have different spaces. So please, I request you not to ask me that one question, because my answer is I use both. So a build management tool is used for compiling, creating executable packages. It is also additionally used for testing, generating reports, documents, and also for deploying your finally built out product onto a repository or a server. The term repository may be a bit alien to some of you. We'll cover and delve into details about what a repository means as well. So what is convention over configuration? This is something quite useful to know before we deep dive into Maven. It's a software design paradigm, and it is essentially used to reduce the number of decisions you make. So for example, if you pick up a software and you have to configure every single element of it, and then you start using it, there is an initial inertia for you to use that software. Apache Maven reduces this by following what's called the principle of least astonishment. So there are like defaults that Apache Maven provides you, and you're allowed to override whatever you feel needs overriding. So you don't have to set up an entire slew of configurations before you start using Apache Maven. By default, it has some conventional defaults, and you're allowed to override them. In addition, Apache Maven also promotes common structures in flow in a project. An example you can see on the right-hand side is the directory structure. Every Apache Maven project almost looks exactly like this, where there's a project under which there is a source and there's a main. And if it's a Java code base, you'll see a source main Java directory tree structure. You can also have resources alongside the Java code. And similarly, parallel to the main, you can have a test directory, which has its own Java code and its own resources used for testing, unit testing primarily, but also for other kinds of testing. At the root of the project, you have something called the pom.xml file, and we will delve into that later. The instruction set for Apache Maven is via a POM, right? And one thing that I wanted to highlight is the convention over configuration is not just limited to this directory structure. In fact, everything you do in Apache Maven is convention over configuration. And we'll see a few examples as we go along. So what is a POM? This is a question that most people immediately ask as soon as we talk about a POM as being the instruction set for Apache Maven. So is a POM a Pomeranian? Is it pomegranate juice? Or is it one of the pom-poms? The right answer is no, none of the above. A POM is a project object model. POM lists what kind of dependencies you use in your project, what are the plugins you use, what are the properties for your project, what are some inheritance details that you have in your project setup, and some profiles. We'll cover some of these in more detail as we go along, but a POM is a project object model. And to just to give you a brief look, and I know I don't expect you to read all of this, I'm just sharing what a POM looks like in an XML format. Maven is a polyglot, which means you can write your POM in not just XML, but in JSON or other language formats, other text formats as well. But in a sense, you have a project, and under a project, you have a model version and some coordinates, such as a group ID, artifact ID, and version, which determine what your end product that you build will have as its coordinates, or how it can be resolved when it is located elsewhere. You can give it a name, it's got a different kind of packaging, some properties, etc. And we'll look into these as we go along through this session. So what are the benefits or usage of Apache Maven before we delve into the, details of Apache Maven itself? It is used for, once you use Apache Maven, you get visibility into your project. Like you have build logs. How was your build structured? How did you build? What succeeded? What failed? You get reusability of builds, which means you can repeat your builds over and over. And you can have composition and hierarchies in that you may have a super POM, and you may just extend from that and create a sub POM for each of your sub projects, but you don't have to repeat yourself. You get verifiability. You produce build test evidence. You get reproducibility again, which is repeatable builds. You have maintainability because now you can manage your builds. Everything is done through a single POM, which means you don't have to run like 10 different things, which you used to do with probably Ant, if you remember those good old days, where Ant would just build your code and you'd have to write separate logic to, let us say, push this code, built out artifact somewhere else, or fetch some properties, assemble something together, or package, was all different, right? So it had to be done using different tools. If you see, Make had the same problems. Apache Maven overcomes these. In addition, you got comprehensibility because the build process becomes extremely easy to understand. It's an XML or a JSON file, which has a standard structure, and you go through that and you exactly understand what your build is going to provide you. That is some of the cheap benefits of using Apache Maven. How is it used? It is used to create, Apache Maven can be used to create any auto-generated code for you. So you may have some templated files, and it can actually produce source code from those templated files. It can be used to generate any documentation from your source code, such as Javadoc or whatever, Xdoclet, etc. It can be used to compile the source code, of course, display any errors and warnings, and test your project using existing unit tests or integration tests that are available under the source test directory. In addition, Apache Maven can be used to package your compiled code into some sort of I guess, executable blobs, such as a jar file, a var file, or a zip file. You can also create exe files, by the way, just letting you know that you use a separate plugin. You could create an exe file as well. In addition, package the source code into a jar or a zip for reference for later purposes, especially if you are some sort of an open source library. You may want to also package the source code for someone to be able to easily go through the actual sources while they're working with your library. You may have better Java doc, or you may have some comments in your code that may help them. It can install the package code onto a repository or server. We'll take a look at that in the next slide. It can be used to generate site reports, as in Apache Maven, the site itself, maven.apache.org, is actually built with every build of Maven, and Maven is used to build Maven, right? So essentially what it does is every time you build the Maven code from GitHub, you actually can download the entire source code from GitHub, and you build this code. It actually generates the entire site, maven.apache.org, on your computer, which you can then push to a host, and lo and behold, you have a newer version of your maven.apache.org, right? It can also report a build as a success or failure, which is what any build tool would do. So Maven is a build management tool because it provides a lot more features on top of what the build tool does. How does it work? This is where I'm going to focus a lot more time, and please feel free to interrupt or ask questions if there's anything you don't understand in the next few slides. So I'm going to ask you to ignore the red box on the top right, because it's more meant for offline or later perusal when you want to understand what these graphics do. But for now, you can just focus your attention on the center and the bottom right, and leave the red box alone for now. It is still available in case you're following along, and if you can speed read as I go through these slides. So let's take an example of a simple Java project, or any other language project for that matter. And you have your application source code, which is in that little black box that you see. That's your application source code. And then there is an internet Maven repository. We'll not name it anything more than that. Just assume that there is somewhere on the internet, some repository that contains a lot of dependencies that you use, libraries that you use. And most of you, if you've worked with Java, are familiar with, you don't just write a program in silo, you depend on other libraries in order to get your program to work. And those libraries are available in what's called a repository. And we'll take a look at how you access this repository in a few minutes. You have this. And then you add what is called a POM file, a project object model file, which has instructions to assemble. It has all the dependencies, that is the libraries and jar files that your project needs, plugins which help you build your code base, profiles which allow you to create different kind of build possibilities. So in some cases, you just want to test. In some cases, you want to create a subset of your libraries, or you want to create a library with a different configuration, etc., is all possible using profiles. And then Maven provides lifecycle build phases, which are declared in your POM. You may not even be aware that these are declared in your POM, but they do come in, and we'll take a look at how they come in a later slide. So the first thing that happens is you download the Apache Maven executable, you point it to your POM XML file. Typically, you navigate to your directory structure where your pom.xml file is located, and then you invoke Apache Maven. We'll not delve into what commands we use right now. We'll go into that later. But once you invoke Apache Maven, it reads your pom.xml file, or your project object model. It goes through your POM XML file, and it combines a lot of different things. It has its own defaults. It has its own convention over configuration defaults. And there are some values it may pick up from other locations we will look at later. And also it reads your POM XML file to find out what kind of dependencies you have, what plugins you have, etc. Everything we list below is all accumulated and created into one object or a POM graph. And we'll talk about that in a bit. So an assemblage of sort happens. Once the assemblage happens, Maven is now aware of what you need. So what it then does is it actually looks for, hey, do I have a copy of all these artifacts that I'm looking for locally? That is called the local repository cache, as you will see in that red database icon towards your bottom right. So it looks locally to find out if there are the dependencies that you're looking for are already available on your computer or host where you're running your Maven command. If it does, it uses those. If it doesn't, it actually reaches out to the internet repository, gets you those dependencies, and pushes these dependencies onto a local repository for future consumption. So Maven reduces your network I/O by first checking your local repository to see that if you have a dependency there, it pulls it from there, else it goes to the internet, gets a dependency, and makes a copy of it on your local repository cache. It could be possible that some of those dependencies exist on your local cache and some are still on the internet, but by the end of your build, everything will be available in your local repository cache. And you're free to wipe it out, but if you wipe it out, your next build will be slower again. So Maven speeds up your builds by creating what's called a local repository cache. So you have this, and then there is either from the Internet Maven repository or from the local repository that you have, Maven pulls in all your dependencies and plugins. Dependencies are libraries that you use in your project to build your project, and your project depends on these to run or to compile. Plugins are also jar files, which are used by Maven to build your project. So the build management uses these jar files or similar in order to build your project. The build management process depends on it. So there are other jar files located at the same locations and pulled the same way as dependencies are, but they're all pulled in by Maven at one single point, dependencies and plugins. Then you have profiles. Profiles allow for alternate executions, alternate configurations, and environment specificity, as we covered before. Those are all sort of calculated, and different profiles are created for Maven to work with your build. And then the lifecycle build phases are executed, which basically either compile your code or test your code or package your code, etc., are all different lifecycles, and we'll take a look at lifecycles in a bit. Just letting you know that those are the execution steps in Maven. Once this process is complete, you have created a final output, assuming your build succeeded. This final output is a jar file, a WAR file, a zip file, or some other similarly packaged archive file, which contains binaries of your compiled code or something similar. These then have to be pushed. The options are you can either not push them at all, which is you're just running your build to test that your code works, or you can push them to a local repository, which means you've not connected to a deployment mechanism that pushes it out to the internet. Or ultimately, you can actually push them out to an Internet Maven repository so other people can access it. So different things are possible with Maven. Maven allows for all these combinations. So just be aware that the Maven lifecycle can either not push an artifact at all anywhere, or push it to your local repository, or push it further down to an internet repository as well for others to access. So that is typically how Maven works. So I'm going to take a quick break and ask if anyone has any questions on the few slides that we've seen together right now. And just to know that this step is optional, because it could be possible that your build doesn't push anything anywhere.
Looks good so far, Chandra. No questions on the chat.
Okay, great. Thank you. So the final version without the notes in there is, this is the whole process where first you download an Apache Maven executable, point it to your POM XML file. It reads your POM based upon the commands you're running. It assembles what instruction set it needs to assemble, determines the dependencies and plugins. Then it goes to either your local repository or the Internet Maven repository, fetches those dependencies and plugins for you, then creates a profile-based instruction set or sets, and execute whichever profile or profiles you selected in your lifecycle, creates an artifact, and either ignores the artifact or pushes it to a local repository or pushes it to the internet. These are the different things Maven can do at a very, very 50,000-foot overview of how Apache Maven works. Great. So the next thing we will take a look at is there is an effective POM. And back in this slide, when we were talking about the assemblage, we talked about profiles. We said that it creates an instruction set with everything. That everything is nothing but an effective POM. So what is an effective POM? An effective POM is an assembly of execution steps. What do you do to build? All the properties in your POM and all the profiles in your POM. So a combination of all the properties that you list saying, hey, I want to use this version of this jar, I want to set this property to be this value, etc., is picked up. The execution steps, what do you want to execute using Maven? Do you want to just build your code? Do you want to test your code? Do you want to package your code, etc., are the execution steps. And then profiles are basically, hey, I want to build for a dev environment, a QA environment. I want this property to have this configuration in this profile versus this value in another configuration, etc., is all set up as an assemblage. And that's what an effective POM first has. And then it has all the content that Maven can execute for your project. So what do I do with this project? Am I building the code? Am I building the test code? Am I running the code? Am I running the test code? Am I executing a certain Java class, etc.? Is the content that Maven can execute for the project, and it collects those. It has an exhaustive set of dependencies and plugins that can be used to do the build. And exhaustive is a very important word here, in that you may list 5 dependencies in your build. these are not just the 5 dependencies you'll get. Dependencies have transitive dependencies. They also get pulled in. So you may depend on a library to do your build, but under the hood, that library may depend on another library. So while you're pulling library one is pulling library 2 and 3 along with it. So that's an exhaustive set of dependencies. Similarly, plugins. You may not list any plugins, but you magically expect Maven to compile your code. There is a plugin for that. A Maven compiler plugin exists, and Maven understands that you're using a Java project, therefore it pulls in the Maven compiler plugin for you. That is through a convention over configuration default that Maven has. It understands that you're running a Java project, you're creating a jar file, therefore you would first want to compile your code, and then it calls the Maven jar plugin in order to create a package jar for whatever source code it compiles. It lists all the dependencies and their transitive dependencies. There is a dependency resolution that we will take a look at in a few minutes. Any potential dependency conflict is resolved at this point. So let's assume you have 2 libraries, library 1 and library 2, and they have sub-dependencies, which are the same coordinates except different versions. Which one would you pick up? Is something that is resolved at this stage in an effective form. So it understands and resolves a dispute of, hey, I'll pick this version over this version, and we'll take a look at the algorithm that Maven uses in a little bit. It is then made ready for execution via Maven executable. In the end, an effective POM looks very similar to a POM, except it is much more larger because it contains conventional defaults that you did not override. And those are superimposed over whatever you set up, and your values take precedence over whatever the defaults were. So you're always going to have the latest version of what you wanted, plus the defaults that Maven provides. So how is the effective POM created? And if you notice the small icons in the towards your right, there are things that you can change and things you shouldn't change, and there are things you can change and should change. So that's how we're going to take a look at it. The first thing is there are Maven internal defaults. Like I first mentioned, Maven is a Java project, and obviously as a part of its classes, there are some defaults that it can provide. So those are called Maven internal defaults. In the jar file, in the Maven jar file, there exists what is called a default POM. That is the base of your effective POM. And this default POM exists in the jar file, and you should ideally not even attempt to override it. Can this be overridden? You can always decompile a jar, pick out the POM file, and then edit it. I would not know why you would do such a thing, so avoid doing that, and actually don't ever do that. Then you have what is called a settings file. And the settings file exists. There are several settings files that you should be aware of. There is a settings file located under the Maven installation. So when you install Maven, Apache Maven, which is a zip file, install is a broadly used term here, you unzip the Maven binary and you get what is called a settings.xml file in where Maven is going to be hosted. Avoid editing that file unless you are making a change on a corporate level. So you should avoid touching that file at all at most points. Then you have a settings.xml file that you manually create. So this settings.xml file is something that doesn't automatically exist, and it is not where Maven is installed. It is something that you create. And then there are very good resources available on the internet which show you how to create a settings.xml file. This settings.xml file resides under your user home. It is not under the Maven installation. Under your user home, there is a directory created when you first use Maven, and it is called a .m2 directory. Under this directory, there exists a settings.xml file, which is picked up by default by Maven. Nothing is preventing you from creating multiple settings XML files with different names. It's just that you will have to provide that named file to Maven, telling it that you're overriding the default settings file and passing it a different named file instead. So you can do that. You can have several settings.xml files. Avoid changing this often, because once you set it up, you probably set up where to go pick up your internet repository details from. You probably set up what you would accept and not accept. Sometimes you don't want, let us say, libraries that are not final, libraries that are still in development, you don't want those. Those are things you set in your user settings file, right? And these are again used by a effective POM because it needs those guidelines to determine which version of the dependency to resolve. So avoid changing it often, but it is something that you do set up from time to time. And then you have some other POMs which are mentioned in green, which is the parent or the BOM file or the bill of materials file. These are something that are controlled by your project or parents of your project. And we'll cover that in a little bit. Just wanted to let you know that is a file that is normally editable, so it does exist. And then there is, of course, the project POM, which is where most of your work should be done. And that is basically a combination of all these creates what is called a read-only effective POM. And you cannot change the effective POM. That is not in your control to change. It basically superimposes, takes the Maven internal defaults, adds the Maven base POM on top of it, applies the global settings, user settings, parent bill of material POMs for inheritance, and then your final project POM on top of it, and creates what is called an effective POM for you. So avoid touching the first four, the top four, and focus more on the bottom two and bottom two above the effective POM, and that's what creates an effective POM for you. So any questions on effective POM before I move into POM hierarchies?
There wasn't a question on effective POM, but in general, I think someone's looking to understand like some tips to make builds faster. If that is something that you can sprinkle, I don't know if that will come up often in the presentation, but that is something that Chirag is interested in, how to make builds faster. So
okay. So Chirag, there is another alternate session that I have, which talks about how to speed up Apache Maven. And I'll give you a very easy hint. It is wait for Apache Maven 4.0.0. It's going to be super fast, and you will be shocked at how fast it works, especially if you're on a Windows or a Linux host right now. Those work amazingly well. You can actually check out the alpha release right away and start using it. Apache Maven 3.x generated, or POMs catered to Apache Maven 3.x still work with 4.0. So you should be able to get away with most of the, I guess, other hurdles. And the builds are super fast. And then I'll explain that if time permits later on as to why that is the case. Anyways, that's a great question. And I'll try to focus on where speed can be improved as we go along. If there are no further questions, I'm going to just jump into POM hierarchies, because this is a somewhat of an alien concept to a lot of folk. So hopefully this will clarify a few details there. There are three different verticals here, and I'd like to focus on the leftmost vertical first, where we're talking about a parentage hierarchy. Let's assume you create a project and it has sub-projects. In your main or the top level project, you can create a POM file, and this POM file may contain dependencies, plugins, and properties that are listed out that your sub-project, which is in this case the second block, another parent POM, can actually read from and inherit, and therefore it now has access to all the dependencies and plugins declared in the parent POM available to it. And then this another parent POM could further be inherited in your project POM, and therefore the dependencies, plugins, and properties of both higher level parents are passed on to the project POM. In this case, the project POM, the bottommost, knows its parents, but the parents don't know the project POM. So the parent has declared itself, but has no clue that there exists a child POM that uses it, right? That's called a parentage-based hierarchy. Hierarchies in Apache Maven are bidirectional. So a parent knows a child may not know a parent in the first columnar values. The second is called an aggregation or a reactor POM. An aggregator POM is one where you have a POM at your root, and then you have submodules, and the root POM knows the order in which you will build the submodules. But the modules have no idea that the aggregator exists. So a module would basically say, hey, I'm buildable. You can build me. I don't depend on any of the POMs, so I'm free to be built. However, an aggregator POM or a reactor POM has an ordered list of modules that it can build. So the aggregator, or the parent in this case, knows the children, but the children don't know the parent, right? You can change all this. You can combine parentage and aggregation into one, but we'll not get into that right away. We'll take a look at it as we go along. The third model is almost like an interface-based approach in Java, where you have a bill of materials. The bill of materials supplies dependencies, plugins, and properties. It does not know of the projects that use it, but the projects that use it depend upon the bill of material to get the dependencies, plugins, or properties included in their own POM files. So a bill of materials is not inheritance, it is more a composition model. And what it does for you is it provides for a default set of values that you can reuse elsewhere, and it has no idea that it is being used. A bill of material POM has no indication of which projects are using it. A very good example of a bill of materials POM is Spring Boot. Spring Boot provides you a BOM file and you use Spring Boot, but Spring Boot has no awareness that your project is a Spring Boot project, right? The Spring developers have no idea that you use Spring Boot unless you go tell them. And that is because they provide a bill of materials file that says, hey, we tested these dependencies and these dependencies work well with this version of Spring. So they've collected a list of dependencies, a list of plugins, and a list of properties, put them together in a bill of materials or a BOM file, and supply it to you. And all you do is you import this bill of materials. You get all those specific dependencies, plugins, and properties now embedded in your own POM file, and therefore your effective POM file. And that is how you get to use Spring Boot in your source code. So it's an import-based model, and it's a composition structure rather than a parentage-based structure. Can these be combined? Yes, you can have any combination of the three of them, but typically combining aggregation and bill of material does not make any sense. So you either use parentage and aggregation or parentage and bill of materials as your two combinations if you want to get more complex. So just be aware of that. And these are the different POM hierarchies. Any questions about the POM hierarchy before we move on? I have examples to show you about these in the next slide.
There is one question. Is the aggregation stack describing how multi-module projects are configured?
Yes, that is exactly what the aggregation stack is. And you will take a look at it in the next slide. Let me just switch over. So same three columns. Here is an example that the leftmost section shows a parentage where I have selected a block which says parent, and it shows that the datetime fetcher artifact depends upon Maven multi POM file. So that is the parentage. In aggregation, I have a multi-module structure. In the center column, you notice that I have a project called Maven Multi. And in this Maven Multi, I have supplied the modules that should be built and the order in which they are being built. That is a datetime fetcher, then a greeting, then a greeting generator. So you notice that I have combined parentage and aggregation in the left and the center columns because they are interdependent. In fact, Maven Multi is the parent and datetime fetcher is the child, and a module in the aggregation. So I've combined those two. A bill of material, I've used Spring Boot here, and we use Spring Framework bill of materials. So it provides for me a set of dependencies, plugins, and properties that I can use in my own application. So I have a Maven Spring BOM file, and in that Maven Spring BOM file, I am importing the Spring Framework BOM. Therefore, I'm getting all the properties, the plugins, and the dependencies that Spring Framework BOM provides, and I can use those. But Spring Framework BOM has no idea that my project exists or uses the BOM, right? That specific version of the BOM. So those are the differences. I don't know if that clarifies the question that was asked earlier. All right. I'm assuming it does. I hear silence. Can you hear me? Am I audible?
Yeah, you're audible. I was just going to come off and say, I guess you answered the question, but I'll keep an eye out on the chat. There is actually one more question, which is about unused dependencies in POM XML and how to identify it and how to remove them.
Okay.
But it's not, I know it might be a separate section in the presentation, but wanted to throw it out there for you.
Great. I'll keep that in mind. I may not cover it as a part of the session, but I can definitely share examples of tools that can work with that. JBoss provides a tool called Tattletale, and it has been around for quite a while and produces reports of unused dependencies. If you use IntelliJ, you get deprecated or unused library warning when you have an IntelliJ ultimate being used. So there are ways to do it, but more often than not, I mean, if you were to create your own effective POM or a dependency tree, you can see hanging dependencies there. So just making you aware that that does exist. Anyways, under the hood, how does Maven work? And this is where the fun begins, right? So we talked about some amount of what the benefits of Maven are. We covered how Maven can be used. We saw how Maven actually works. We went through how different parent hierarchies exist, what an effective POM is, etc. But how does Maven work under the hood? This is where the fun begins, in that Maven provides you 3 standard life cycles as of the Maven version 3. Maven version 4 creates a 4th. I will not talk about that. I'll leave that in suspense for my next session some other time. But there are 3 standard life cycles currently available in Maven. There's a clean life cycle, a build life cycle, and a site life cycle. A clean life cycle is typically used to clean your project code base of any artifacts that were left hanging from a previous build. So let's assume you build a project similar to how there is a source main Java, a source test Java. Maven, upon compiling your code, produces a target directory and compiles your code and sort of serializes the class files there, right? So those exist in the same project structure, and they look dirty because they're not something you push out into your version control system, which means you have to occasionally clean your source code. Or when you're building fresh, you don't want stale versions of the classes being available, which is when you'll also run the clean. So clean is a life cycle. The dark gray, I guess, circle, rectangle, whatever that is called, the oval shaped, are all life cycles. There's a clean life cycle. There is a default life cycle, which is called the build life cycle. Just don't refer to it by that. It's the default life cycle. And there's a site life cycle, which allows you to build the site documentation. The way Maven works is these life cycles by themselves are meaningless. They have phases. So when you invoke a lifecycle, you typically invoke a phase in that lifecycle. And the way standard Maven usage is you would call the clean phase of the clean lifecycle and probably call either the validate, test, package, or verify or install on the build phase. Those are the typical, I guess, commands that you use in Maven. But how does it work? When I call Maven clean compile, for example, what is happening? I'm calling the clean : clean, which is the default phase in the clean lifecycle, which means Maven will first run the Maven clean : pre-clean, then it will run the Maven clean : clean, and that's where it stops. And then my second part of the command was in the Maven clean compile was the compile. So Maven will then call the build lifecycle. In the build lifecycle, it will call validate, initialize, generate sources, process sources, generate resources, process resources, and then compile and stop there. So Maven calls every single phase until the phase that you put on the command line is reached. Okay, so all those prior phases are also invoked in the order in which they are listed. So there are 23 phases that you see in the build life cycle. And when you call, say, package, everything prior to package is first invoked in that order until it reaches package and executes it. So you still get the validation, you still get the initialization, etc. when you call package. So be aware of that. And when you call Maven clean, you're calling the life cycle. You're not calling the phase. But under the hood, the clean is a clean : clean. That's the default phase of the clean life cycle. Similarly, when you call Maven site, you're actually calling Maven site : site. So a pre-site will get executed, then the site will get executed. So just to summarize this in text, when I call a Maven clean compile, it first calls the clean : clean, because clean is the default phase of the lifecycle clean, which means it calls the pre-clean and then the clean. And then on the default lifecycle, it calls validate, initialize, etc. until it reaches compile. So this is how Maven executes lifecycles. And this is very important to know. And a lot of people sort of miss out on this detail. Now, back in this picture, you notice that some of those, the default phases are shown in red. My apologies for anyone who's got color challenges. I tried to make it as color friendly as I could. However, you will also notice that there are some phases in the default lifecycle which are shown in lighter shades. These are generally not invoked from a command line, and these are special cases to invoke them directly. So most of your IDEs will probably show the darker shaded default phases when you look up a Maven lifecycle. So if you open IntelliJ, for example, and you go to your Maven tool window, you'll see validate, initialize, compile, process, testers, etc. You may not see generate sources. You may not see process sources. Don't worry. They are not typically called, so they don't show up in the Maven tool window. There are ways in which you can execute them. Same from a command line. Typically, you would call a validate or initialize. The ones in gray leave your source code in a hanging state, and you don't want that. You don't want to call pre-integration test or post-integration test. Verify actually calls those. So you are better off using verify than calling, let us say, a pre-integration test. And that is why those are marked in gray. So I don't know if anyone has questions about that. I'll just wait for a second.
I do have one question, Chandra.
Sure.
While, if someone else has other questions, feel free to post them on the chat as well. So if, let's say, we did Maven compile, would clean still get executed?
No.
So
no.
Maven compile would only do the phase that,
yeah. Yes. So when you specifically have to call out the lifecycle for it to be executed, So if you just call Maven compile, then the only things that would happen is a validate, initialize, so on until compile. That's it. Nothing else will be executed.
No
right.
other questions on the chat. You can go ahead. Yeah.
Awesome.
Thank you.
Awesome. So while we covered life cycles, and life cycles are cool, we got all these life cycles here, and we know that when we invoke a command, we know what Maven is doing under the hood. It feels nice. Well, let me tell you something. The life cycles in Maven do nothing. They are absolutely useless. They don't do anything by themselves. What happens is there are jar files called libraries, plugins, and these plugins attach themselves to the lifecycle phases. And when you invoke a phase, all plugins or goals associated with a phase are what get executed. Okay, so lifecycle phase means nothing. It is just, hey, it says, hey, this phase has been initiated. And it means nothing. It doesn't do anything. It looks for all plugins which have goals, and these goals that are associated with that specific phase get executed. The order in which they get executed is the order in which the plugins are listed in the effective POM. So a lifecycle phase, although a very theoretically great concept, does nothing for you except look for hooked up plugins. A plugin is a jar file for most part, and the jar file contains, I guess, Java classes called mojos, Maven old Java objects, and these mojos are referred to as goals. And a goal has a name with which you can invoke the goal, and a goal may have an associated phase, and that phase associates with some lifecycles phase. So can you create your own clean plugin? Yes, you can, and you're free to. And there are ways in which you can override how Maven can stop using the Maven clean. Hello, was there a question? I'm assuming that was just an interruption there. All right. So Maven has an ability to override its own defaults, as we've talked about, convention over configuration, and you can override the default plugins that Maven uses and replace them with your own plugins, and it is possible. It is also possible for you to execute goals by simply calling them. You know your coordinates, the group ID, artifact ID, and version of the plugin. You know the goal name, which is a prefix that you can provide, and that goal will be executed for you. So you just don't have to depend upon the lifecycle phases. You can also directly call a plugin that you establish in your POM file. So you can create a plugin that's not associated with any phase and invoke it from the command line alongside your regular usage. So I could do Maven clean, and let's assume my plugin is called foobar. I could say Maven clean and then foobar : goal, and that particular plugin's goal will also be executed after the clean phase is executed. Okay, so Maven provides you the ability to either attach yourself to a lifecycle, call the lifecycle, or specifically call a plugin and its goal, which is not associated to any phase. So that is how Maven actually works under the hood. Plugins are the most important executables in Maven. A lifecycle is something that is just invoked based upon your commands. So be aware of this. You can do more than just call the lifecycle phases. You can also call plugin and their goals directly. Okay. Usually you should have a very good reason to do this, but there are sometimes some plugins and goals that have no association with any known phase, but you want to execute them anyways. An example could be, you go to your Maven command prompt and you want to see the dependency tree structure of your Maven project. And then you will execute a plugin called Maven dependency : tree, which is not a standard goal. It's not associated with any phase, but it will produce a dependency tree of all your dependencies, right? So therein, you can just say Maven clean dependency : tree, and it executes that for you. Awesome. Any questions on plugins? Well, everything I just talked about is listed here in a text format. A lifecycle phase by itself does not do anything. Tasks are performed by plugins. Plugins allow phases to carry out their responsibilities. Plugins declare goals. A plugin goal may be bound to 0 or more lifecycle phases, and default bindings of a lifecycle phase may depend upon the packaging. Right? So if you just use a regular Java code and you set the packaging to, let's say, jar, or you don't set it to anything, the default is a jar, then the Maven jar plugin is called. But if you want to change the packaging to, let us say, EJB, then instead of a Maven jar plugin, a Maven EJB plugin is called. If the generate resources phase, in case of an EAR file, we'll call it generate application YAML from Maven EAR plugin, right? So there are different kinds of plugins that can be used. And once again, these are convention over configuration standards that Maven provides and allows you to override. So just be aware of this. There are lifecycles and there are plugins, and Maven uses lifecycles so that plugins can associate their goals to them, and those goals get executed when the phase is reached. The final part of my session today is about dependencies, and dependencies is very interesting in Maven, so I want to spend like 5 minutes on this. When you include a dependency, let's say what's the yellow box number 1 or the yellow circle number 1 is something you include in your POM. That is the dependency you include. And that dependency has further transitive dependencies on 2, 3, and 4. Therefore, by you adding 1 to your POM XML file, 2, 3, and 4, and their subdependencies or transitive dependencies all get pulled. Now, let's assume you don't want 4. There is a way for you to exclude that using an exclusions criteria. So, and once you create a dependency, you can say, hey, get me all transitive except exclude this one specific dependency. So 4 can be dropped. So once 4 is dropped, any transitives of 4 are also dropped, right? So then you get only the right-hand side and the center of the graph. You don't get, you get the left-hand side and the center of the graph. You don't get the right-hand side. In addition, Maven also provides you with dependency optionality in that, hey, if you include this jar, I will pull it for you. But if you don't, I'm going to assume you don't need it, and therefore I won't pull it for you. A standard example is, let's assume you have your own application and you use your own logging using SLF4j. You may depend on a library that also uses SLF4j and log4j under the hood. Now, they don't need to bring in the log4j because you could have a different version of it. So they will mark their SLF4j or log4j as optional. Now, if you were to mark them as not optional or you pull them in, they are brought in. Otherwise, they're assumed not needed and they're not pulled in. However, the optional is useful because that library needs it to compile and run. But if you have a different version, your version will get precedence over whatever is set in that particular library. And that is the usefulness of dependency trees. Any question about what I explained on this slide? Okay, I hear silence, so I'm just going to keep going. Now, here is some amount of interactivity. Take a look at this. There are 4 dependencies I add into my POM. There is D1, D2, D3, and D4. And they have transitives. In case of D1, I have D11 as a dependency, which has a further dependency on DX, version 1.0.0. And then I have D2, which has a dependency on DX version 1.2.0. D3 has a graph of D31, D311, which has a subdependency on DX 1.3.0. And D4 has a dependency on DX version 1.5.0. Which version of DX will get pulled here? Can anyone answer me this? Anybody? Take a guess. There are no wrong answers. Well, there are.
I don't know. I think it's version 1. I don't know.
Okay. Okay. Any other takers? Anyone else?
Yeah. I'm looking at the chat to see if someone wants to say something.
Okay.
Philip, you want to take a shot at it?
No? Okay. I don't want to waste time.
I think it's a version 1.
Version 1? Okay.
Yeah.
All right. So let's take a quick look. The version that you will pick up is version 1.2.0 and not the others. And the reason is because this is how Maven dependency resolution happens. Let's take D1, for example. D1 has a dependency on D11, which has a dependency on DX. It is not the nearest depth. It is further down. Now, the nearest depth in this chart is either D2 or D4's dependency DX. D2's dependency DX comes first. So nearest and first is D2's dependency DX. D3 is too deep. It's going to be ignored, although the version number looks bigger than the version that we selected. So 1.3.0 is ignored because 1.2.0 is nearer in depth. D4 has the biggest version number, 1.5.0, but it is ignored because 1.2.0 is both nearest in depth and first in resolution. And that is how Maven works. Maven does not do digit comparison in versions because versions can be strings. So be aware of this. If you really want 1.5.0 to be used, you should either add a dependency DX in your POM with version 1.5.0 or move D4 to above D2. That is how you decide which version of the dependency you get. The best solution is not to have the ambiguity and add DX directly to your POM with the version you want. If you don't, you will always end up with the dependency or the transitive that is nearest in depth and first in resolution. So be aware of this. Any questions on this slide?
Oh, this is great. That's actually one of the questions I was having in my project. I have 2 dependencies, and one is I know the order doesn't matter, but I didn't know this nearest, right? This is really good to know.
Good. I'm glad. All right, so that's all we have time for. And if you have further questions, feel free to reach out to me on Twitter. I do have a lot more slides, so don't get me wrong. I have, if you want me to continue talking, I have a lot more slides in the appendix. I'll just very quickly walk you through it in 2 seconds, if you, Renad and Sirisha, don't mind. So here is the POM reference for the project, like actual Maven POM. What does it contain? Anything in dark black is basically a complex object, which means it has further hierarchies. Anything that is in a background box is further expanded on in future slides. So build, profiles, dependencies, and dependency management. Anything in the shade of gray is simple entities. They just have values. They are just single line entities. They are not complex. So you have parent, group ID, artifact ID, and version, which are coordinates with which you can identify the dependency that you're going for. In addition, there are other fields such as classifier, scope, etc., which we did not cover here. I can do a more in-depth talk some other time if you're interested in those. But let's go very quickly further deep. The build itself has a lot of data. Your default source directory, script source directory exists, but you can override those, avoid overriding them. And then you have extensions, resources, etc., which are complex objects. And then you have plugin and plugin management. Dependency and dependency management both have dependencies as one of their children, and each dependencies object has a dependency child objects within it. Each dependency has a group ID, artifact ID, and version, and further classifier, type, scope, etc., to further, fine-grain the dependency that you want to get. In addition, you have exclusions that we talked about, which allows you to ignore transitives that you don't want picked up. Plugins or plugin management both have a plugin section, and plugins have very similar to dependencies, got a group ID, artifact ID, version. They don't have a scope. They don't have a classifier, but you can always add one and use it. And then it has executions. So this is where you can associate a plugin goal to a phase. And you can see that in action in this particular graph. And you can also configure the plugin to act or behave differently. And it, of course, has dependencies. So plugins may have dependencies that they use in order to execute. They may need to depend on other libraries too. So, and the last part is the profiles, which have a profile ID, whether it is active or inactive or activated by some condition, where its output directory is, how you are distributing your projects. The same exists in build, dependency management, distribution management, properties, reporting. Same values that exist in a build also exist in profiles, because you can actually create multiple build profiles for your build management tool. And then, of course, there's a how you configure Apache Maven. There are different ways to configure. You have environment variables. You have some config files that you can edit. You can Google these. And then you, of course, have XML configurations. Global settings XML file. You don't want to touch this. User settings XML file. You don't want to often touch this. Your extensions.xml under your project. Your tools change.xml under your project. Or your user home, which is standard across a lot of projects that you have. And for your specific project, you have a tool change.xml file. So, and these are different things. I mean, how does a Maven lifecycle work? What are the different versioning strategies I mentioned about? You don't want versions that are currently in development. You want final versions. This is the lifecycle. You start your development, you test and you bug fix, etc., and you create what is called a snapshot. And you put it into a snapshot registry. People can test with this. It is not supposed to be productionized, but it's available for people to test a newer version of a feature. So once you're done, you probably find other bugs and you go back through the cycle. But once you think that all bugs are addressed and features are complete, you can create what is called a release, which goes to a release repository in Maven. And this is final and immutable. It can never be changed. The development snapshots can be overridden. So the same version number can be overridden multiple times. So they are unstable, mutable, and you should always be wary of using them. However, once you create a release artifact that's immutable, never changes, and once you're done with that, you have to create a new version and go back into the cycle. So this is just generally a Maven lifecycle when you use when you create a project using Maven. Be aware of this. I'm going to make these slides available to you. I'll send them over to Renat and Sirisha, who can distribute them or upload them to wherever. But should you have further questions, please feel free to reach out to me. Thank you so much for your time.
Chandra, everyone's already asking for a November session for a sequel. But no, this was great. I think we use these tools so often, but just knowing about how it works behind the scenes is very, very helpful and useful.
Great.
You use it correctly, I suppose. Yeah, that's the right thing to say. I don't see any other questions. I guess everyone's thanking you, and thanks a lot, Chandra, for joining our session today, and for Chandra Guntur, I think that's right. For everyone else, I think we will upload the recorded version of this on our YouTube channel. I posted that on our chat as well, so you can subscribe to the channel to get notified when this recording is up. So yeah, that's about it. Renat, do you?
No, I was just gonna say that we'll upload it when it's available. And thank you so much, Chandra.
Yeah,
Thank you, Chandra, and thank you everyone for joining us. Yes.
Yeah.
Thank you. Yeah. Have a good night.
Have a good night, everyone.
Bye bye.
Thank you.
Bye.
Bye.